Alright, so welcome back. So today we're just going to be looking at how to form or the formation of ionic bonds. Now we kind of touched up on this rule, and I might have mentioned when you did Science 10, is that bonding tends to follow something called the octet rule. So it states that when bonds form between atoms, the atoms either gain, lose, or share their bonding electrons in such a way that they create outer energy levels with paired electrons. Or another way to think about it, they're going to do this until every single orbital is full. Or, in the case of metals, full or empty. That's supposed to be an M, not empty. There you go. So traditionally, when we looked at this, or how you thought about an ionic bond, was that it was a reaction between a metal and a nonmetal. However, we now define it as a bond between a cation and a anion. All right. So that's because, like, even think about the polyatomics and how a polyatomic technically isn't a non-metal atom; it's a bunch of atoms. So we're going to use this idea that it's just a cation and an anion attracted by their positive and negative charges. Now, how we showed the formation of ionic compounds in the past, we used the drop and swap, and that gave us our empirical formula. So the experimentally determined simplest whole number ratios of atoms or ions in a compound. This is why we used a drop and swap, and why we actually had to use lowest common denominators too if we had something like calcium sulfate, which we'll get to. Now, the empirical formulas are mostly used for ionic compounds. Now, once again, we've done the Science 10 review. So just a reminder, when we do drop and swap, like iron 3 sulfide, we wrote our iron out with the charge, we write the sulfide with its charge, and of course when we did our drop and swap, we dropped the number down and we brought it in front of the one atom, and we did the same with the other. So for example, iron 3 sulfide would be Fe2S3. Now for calcium sulfate, right, we always had to be careful with ones like this, because if we dropped and swap, we would end up with Ca2SO42. But we always say we need to get it down in lowest common multiple or lowest common denominator, or whatever you want to say. I think common multiple will probably be the correct term for it, or our simplest whole number ratios. So calcium sulfate turned into CaSO4. And that is it. So we're going to look at why we do that now in a sec. And it's all from the formation of ionic bonds. So, first, the theory behind this. So, atoms become ionized by gaining or losing electrons. So, if we remember about the whole idea about electronegativities, metals have very low electronegativities, so they're going to lose their electrons to become a cation. This process is called oxidation. Losing electrons, oxidation. Metals have a high electronegativity, generally speaking, so they're going to gain their electrons, and this is called reduction. So we really dive into this in Chem 30 when we have an entire unit on electrochemistry, but just for right now, just know metals lose electrons, that is oxidation. Non-metals gain electrons, that is reduction. Now, an acronym you can use for this is something called oil rig. So OIL, oxidation, is a loss of electrons, and reduction is a gain of electrons. So when we're trying to determine the charges, we've already looked at how to do it with our group A's, and that is we look at what numbers associated with it, right? So we only look at the A ones, right? So 2A, there's 2, 3, and so on. Now our transition metals, we don't do it with those there. So transition metals, the number of valence electrons is not always obvious. So we cannot always predict the charge on the ion. But if we have to, we need to use the most common ion charge, and that is the charge on the top right. So for example, if we have something like manganese, the one on the top left on your periodic table is 2+. So if you don't know what it's going to turn into, we assume 2+. Chromium 3+, iron 3+, cobalt 2+. Now if it tells us we have nickel 3 something, right, obviously we need to use the 3+ charge. But if it's not given to you, assume the most common. Now, one of the rules that we are going to have is that the total number of electrons lost by the metal must equal the total number of electrons gained by the nonmetal until we have a net neutral charge. And that is because no compound out there is going to be charged. If it's charged, it is an ion. If it's an atom or a compound, it is neutrally charged. So that means the total positive charge must equal the total negative charge. For example, sodium chloride. We see sodium +1, chlorine 1-. If we add a +1 and a 1- together, we get a 0 charge. So all ionic compounds need to equal out a 0 charge when you're done. And what an ionic bond is just the attraction between the positive cation and the negative anion. That is our ionic bond. So, how do we represent this? When we show the formation of ionic compounds using our Lewis models, we have to make sure that all metallic atoms will lose their electrons and nonmetals gain them. All right? Now, we are going to use two diagrams to show the formation of ionic compounds. Diagram 1 will show the transfer of the electrons using arrows. Diagram 2 is going to show the electrostatic attraction between the ions. Okay? So, just so you know, we need two diagrams to show the bonding of ionic compounds to receive full marks on tests. So, I'm going to do two examples and let you guys do the rest. So, we are going to show or draw Lewis models explaining the formation of calcium oxide. Now, we've already done calcium oxide on the back page, or actually, no, we never. It was calcium sulfate. But we know calcium oxide, if we did our drop-in salt, we got Ca2 plus O2 minus. And we know when these come together, right, we'll get Ca2O2, and then we bring it down to CaO. So the reason we do that is that when we look at this empirical formula, it's one calcium atom and one oxygen atom bonding, not two calciums and two oxygens. And the reason for that is what I'm going to show you here. So our calcium Lewis diagram is Ca with 2 electrons. Now our oxygen, I'm going to do this in a different color just so we can see where the electrons are going. Oxygen is in position 6A, so it has 6 valence electrons. Now, when we are showing the bonding, we need to show this bonding electron is going to leave calcium and now pair up with that bonding electron for oxygen. And same thing, this electron is going to leave calcium and go over and pair up with that electron. So what we are left with is we have calcium. Now, normally you use square brackets around these when you're showing the bond, so you can keep them in or leave them. I'm not really too picky as long as you show the dots and the charges. I'm just going to put in square brackets for here, so we have calcium 2 plus. Now, as for our oxygen, O, the original electrons for oxygen were here, but now it picked up 2 of calcium's electrons, just like that. And we have our 2 minus charge. So notice, if we did out the math, right, you don't need to show this, but everything needs to be neutral. If we did 2 positive plus 2 negative, we have 0. It is neutral. And notice how we have 1 calcium and 1 oxygen, so the chemical formula CaO. That is why the drop and swap works when you need to get lowest common multiples. Now, not all of them are going to work out like this. Sometimes we'll need to add more. So, let's look at next one. So, show the bonding of lithium sulfide. Now, I always like to do the drop and swap first, just so I can get an idea of the chemical formula. So, lithium sulfide, Li, 1 plus, sulfur is 2 minus. When we do our drop and swap, we should get Li2S. So this is the empirical formula for lithium sulfide. So notice how this formula is telling us we have 2 lithiums and 1 sulfur. So why does the ionic compound exist that way? I know what it did for the drop and swap, but now we're going to show why it exists this way. So same thing, lithium. For our molecular form, Lewis dot diagram for lithium, it is in group 1A, so it's Li with 1 electron. Now when we look at it pairing with sulfur, S, 1, 2, 3, 4, 5, and 6. Because sulfur is in group 6A, so it has 6 electrons. Now, if you wrote just 1 lithium and 1 sulfur, you'll notice that we can transfer this electron, so this bonding electron from lithium over to that bonding electron from sulfur. Now, that's fine. So this lithium right now has a complete empty shell at around everything, but sulfur isn't full yet. It still needs one more electron. So that's why we need to bring one more lithium. So that lithium can now share its electron with that last bonding electron from sulfur. So what we're left with, we got 2 lithium ions. That's positive 1 charge. And we got our sulfur that now has a complete octet. It has 8 electrons, and its charge is 2 minus. And notice we have 2 lithiums, so technically the chemical formula we just showed right here is Li2 and 1 sulfur S. And if you did want to just double make sure, does it equal a net neutral charge? We got positive 1, negative 2. So positive 1 plus a positive 1 plus a 2 negative. You add those all together and you get 0 charge. You don't need to show this, it's just making sure that your ionic compound is neutral. And that is how we show our ionic bonds. So remember, 2 diagrams for each. Now I'm not always going to have them diagram 1 and diagram 2. They're going to look like this. Boom, practice. So there's some here to practice. Once again, you want to try this and then go ahead and hop onto your CYU booklet and try the ones under this section. And tomorrow, next lesson is going to be on molecular compounds, so we're going to look at those. But you want to make sure that you get these down as well. All right, so the formation of the ionic bonds, just show the 2 diagrams by yourself. Okay? If you want to see the answers, hop on Google Classroom, look up the answer key, and double check, see if you're getting your answers right. And if you're not, see if you can figure it out from the answers that are provided. But if you're really having trouble, make sure to email me, and we can set up either a Google Meet, we can meet after school, in class, or whatever your next available time. All right, that is it for this one. See you guys later.